Hello, my name is Mabel Sito. I am part of Team Inspiration and also part of WeSTEM, which are the two clubs that are hosting this event. Team Inspiration is a robotics team located here in San Diego. We are a community robotics team, and WeSTEM is a SWE Next club. So SWE is the Society of Women's Engineers, and SWE Next is the K-12 branch. And we hosted this speaker series to kind of share the variety of STEM fields that there are and see the different applications that STEM can have. Also here are Ashiria and Ashika, who will be the two leads for this club as I graduate. And for everyone who has joined the meeting, we have a short check-in form just to see where you're from and who is here out of all the people. So I think we have most of the people so far. So if you're just joined, please fill in. Oops, I will send it again. But there's a check-in form. If you haven't done that, please do so now. And I think we can start. So Gabriela is a systems engineer at Northrop Grumman, and she will be presenting on Agile systems engineering to all of us. Agile is a special type of systems engineering, and it's really applicable to software especially, which I know a lot of our audience members are from the high school computer science classes. So I hope you guys enjoy this presentation. And Gabriela, if you want to start.
Sure. So first of all, thank you so much for having me today. It's really an inspiration to talk to you guys, Team Inspiration, right? You guys do some of the things that are close and near to my heart. So without further ado, I'm going to try and address the topic of Agile systems engineering. I am a systems engineer at heart and by training, and I am an Agile practitioner, still learning about the different processes and different applications of Agile. So keep that in mind. So to give you a little bit of background about myself, first of all, this morning I was thinking about, oh my goodness, what should I wear? What should be the attire for this presentation? And I kind of went back and forth. Do I, wear a suit, or am I going to present myself a little more casual? And then as I was going through my closet, I found one of my favorite shirts. I don't know if you can see it. It's Northrop Grumman SWE shirt, or Society of Women Engineers. And in the back, it says, this is what a Northrop Grumman engineer looks like. So as you can see, our company is very diverse. And when we go to SWE, we like to represent ourselves as a company, right? And our diversity. Our company is very diverse, and I am so very proud to have been working here for a little bit over 25 years. So I'm a consultant engineer and a technical fellow. And one of my things is really to advocate for women in engineering and STEM. I'm a mentor, and I mentor folks or young people, and also peers across various opportunities that I have. One of the things that I recently launched, and as a result of COVID, because I found myself during the weekends having a little bit more time than usual, I launched my podcast, which is Keys to the Future. So I invite you to listen to it if you like, or check it out on wherever you listen to your podcast. I am an Nkosi Isa, expert systems engineer professional. And I was so excited to also hear that this forum is really associated with all those organizations that are really close and near to my heart, SWE and Nkosi. I have a Bachelor of Science in Industrial Engineering from the University of Miami, and a Master of Science in Systems Engineering from Virginia Tech, in short. You can look me up on LinkedIn, and if you want to connect, I'd be happy to. So let's see. we talk about systems engineering, right? And our heritage Northrop Grumman companies evolved the term we now know as systems engineering in order to develop solutions for tough customer problems, requiring large and complex systems and coordination among not only our teams internally, but suppliers and our customers. So looking at these three definitions, starting with the Simon Ramo definition, and Simon Ramo is known as the father of systems engineering, and he was from one of our legacy companies. So you can see the definitions from his definition to our current enterprise level systems engineering procedure. I like to really like you to note the phrases highlighted in blue. And for those familiar with Agile practices, you can see that the adaptive nature of systems engineering is highly aligned with Agile best practices. So what do systems engineers do? What is it that we do? What do we mean when we say design of the whole? Well, the design of the whole is systems thinking, having that holistic approach to looking at a problem and potential solutions. What do we mean by interdisciplinary collaborative approaches? Again, that's having that systems thinking, right? And applying the interdisciplinary or all the disciplines, looking at the problem that we're trying to solve and looking at across the disciplines that are needed to have to evaluate that problem and to apply those aspects so that we can effectively resolve a problem for our customers, not to work in separate silos as we know them, or separate teams, and each team looking at the problem, at a time, but rather collaboratively, we're looking at the problem that we're trying to solve for our customers in a holistic way, applying all the discipline aspects that we need to look at in order to have an effective solution for our customers. So then we talk about discipline iterative process that allows us to evolve and mature the system to meet our customers' expectations. So that means that we systematically dissect that problem and systematically also look for the best potential solution. So what do systems engineers do? Are we just requirements people? Are we just writing requirements or just writing documents that people never read? I'll tell you, I've been in this business for 25 years and maybe a little over that. And that's just not the case. So I am glad to tell you that we have a very important role to play in systems engineering. So first and foremost, systems engineers, we are storytellers. We manage and communicate the story of the system from the beginning to the middle to the end, so that everybody touching that system, from the business development teams to the development teams, right? And that development teams really encompass not just the software engineers or systems engineer, that encompasses everyone that's going to develop that solution, a solution for a customer's problem. So everybody needs to have a consistent, even the customer, consistent understanding of what that system is supposed to do, in what conditions, and in what interactions and standards are needed. So we ensure that the story is comprehensive, coherent, and consistent throughout the life cycle. So think of a systems engineer as the person putting together that puzzle, right? When we put together a puzzle, we have that box that tells us what that end game, what that end picture is going to look like. Systems engineers don't necessarily have that box at the end that tells you this is what your solution will look like. But as we start to evaluate the problem and think of potential solutions, we start to form that picture and understand the different components that we need to apply, understand how they work together, understand how they may interact, not only the components themselves, but also the people that will be interacting with the systems. And then we also need to think about that component level, and then the system, the subsystems that would make up a system, and then even larger than that, the system of systems, right? So we need to understand the whole picture and how these different pieces go together. So I like to give that analogy because when you have a big puzzle, you can have thousands of pieces puzzle, right? And you start putting it together, you may not know exactly what piece goes with another piece, but as you start forming the bigger picture, then you may know more about where to put a specific piece. So systems engineers do, we do not only just write requirements, which is great, we innovate, we understand how those pieces need to go together, and then start to form that bigger picture for our teams, our customer, help them understand the story of that system, how they're going to use it, first of all, how we're going to develop the solution, and then how our customer is going to use it. So that is the story that we need to tell and have a coherent story from end to end, right? From beginning to the middle to the end. So systems engineers do all of this, plus even more, to fulfill our responsibility to clearly communicate that persistent story of what the functioning system is to do. So before we get into the Agile best practices, I'd like to take a look. We're taking a look at the historic approach to large scale systems engineering and their development. We also need to look at the waterfall approach. As you see here, these are all of the steps that are needed for software, for the system development. So a version of this diagram appeared on page 2 of a 9-page report that was presented by Dr. Winston Royce at a IEEE conference back in the 1970s. And Dr. Royce was an American computer scientist well known for his pioneer activities in the field of software development. So he, unfortunately though, it seems like the industry never got past page 2. As of at the top of page 3, Dr. Royce made this comment that you see here on the slide. He believed that these were all important parts of developing a working product, but to execute these practices in a less risky manner required modification, including a greater emphasis on design, good documentation to ensure that knowledge and system intent carried through the development cycle. The use of prototyping to clarify requirements and thorough testing, and most importantly, having the customer and stakeholders involved in each step of the process, because then you get that feedback that you from the customer, from the user, so that you're able to have improvements right away, not down the line when it's more costly to either retrofit or redo, rework, and so on. So if you look at this 30+ years before Agile methodology, Dr. Royce was already recommending that we apply some of this Agile best practices that we now are recommending as Agile practitioners. So what are some of the realities that makes us look at these modifications? Let's take a look at the current the waterfall, some of the waterfall realities, right? We process realities rather than myths. Systems engineers have that responsibility to help our teams and customers navigate to the non-ideal reality successful. So systems engineering has a role of taking that what, right, and turning it into the most practical. This is what you can have based on the constraints that we're working through. So let's take a look at these myths and realities. The very, very first one, well-defined, stable, and consistent requirements at project onset. Let me tell you, I have not worked in a project where that has been the case ever. So the reality is that we systems engineers need to deal with instability of requirements and help our customer evolve those requirements as we learn more about what the problem it is that we're trying to solve and the potential solutions that we can apply. The second myth is customer resources consistent with requirements. Again, I have not worked in a project where that has been the case. So systems engineers must work with customer to perform cost trades if desired functionality exceeds the budget. And those are the trade studies that we can do to evaluate potential solutions to then select the best feasible solution given the constraints that we have to live with. Then the third one that you see here is design begins with a clean sheet of paper. False again, because in my career, I have not really had, maybe once where we started out with green fielding, if you will, which is like brand new development. And even so, we have to really consider what all the other constraints that are imposed by history, politics, or the current state of technology. How are we going to incorporate this brand new system or brand new subsystem or brand new component with a legacy system or component or subsystem? How are we going to incorporate that? So that's really not really a clean sheet of paper, right? And then the last one here, systems engineering can be driven top down to product development. The reality is that systems engineering must leverage heritage design and supplier expertise because at the end of the day, we need suppliers, we need stakeholder input. And then having that top down, but also the bottoms up come together is what we need to have that approach and create the handshake between the customer and the implementers and potential suppliers, having that big picture, having that understanding of that story of what the system is supposed to do, right? If the stakeholders, the customer, the implementers, the suppliers have a really good understanding of the story of that system, what that system is supposed to do, what it's supposed to integrate with, what it's supposed to interface with, and so on, then that helps us drive down that top down and bring up that bottoms up. So our customers now are realizing that Agile best practices is what they need to have their products faster. And so our customers, we help them meet their ever-changing mission needs. Their missions are changing so rapidly. Prime example, it was the pandemic. We saw how the pandemic, their mission needs really changed. And in a dime, we had to, turn around solutions that were feasible for our customers to continue to perform in their business and to continue in some cases, continue to have their business afloat. So they are beginning to shift and realize that change is inevitable. And customers want to collaborate from the onset. They want to be involved. They want to learn those that have constraints, but they want to also learn how we can work around those constraints, how we can incorporate those constraints into the potential solution. A workable answer to this is dealing with an imperfectly defined and realized requirement space. Is to solve the problem a bit at a time so we can apply Agile best practices such that through incremental learning, we can define and refine and prioritize those requirements and evolve the system. Prioritize because we can't have all the functionality that the customer may want all at once, right? Because we have to be realistic. Do we have the budget to have all that functionality at once? Well, then we ask the customer to prioritize. Well, if you want to have this now, what can we delay to later releases or a later functionality based on the constraints that we're working with? So those are the types of realities that we systems engineers look at. So this provokes requirements change early in the program rather than later, which is really helpful, because if you were to change requirements once a system or component is down the line in integration and testing, or even more so in operations, that is very costly to fix and rework. That technical debt that we talk about is what the companies developing the product have to pay for doing rework. So we want to minimize that as much as possible. So we go on a journey with the customer to define a series of minimum viable products, or MVPs as is known in Agile, that define, refine our understanding and deliver that technology while it's still relevant, right? Because we know nowadays technology, we have tools today that are brand new today, 2 weeks from now, and they're not as brand new as they were today. So we need to keep up with those realities as well. So as you can see here on the left-hand side, Agile answers the stated goals, but by delivering what we promise, we ensure best quality and value to people in society, because we really need to have our people being able to have that innovation, that time to innovate and maximize the customer satisfaction by providing them what they see of value quicker, and having that team morale and safety also increase, because you're having your workforce, your teams creatively engaged in solving tough problems for our customers, and giving them something that they're really going to use rather than right away, rather than later on in something that may be, this is too clunky, let's go back and fix it. So we minimize waste as well. So you see that the Agile answers these stated goals, building on this heritage of lean development and focusing on that sustained value stream. And what is a value stream? The value stream are all the activities that need to happen from the time that customer places that order or tells you, I need your help in solving this problem, to the time that customer gets that solution or that product. So there's a lot of teams involved, composed of, systems engineers. It could be hardware engineers, software engineers, the suppliers, stakeholders, users, and so on, right? So we need to make sure that we have that continuous flow by working in small batches, which is incremental functionality that gets that feedback from each step, that allows us to learn and apply those lessons learned as early as possible in the process. This really fosters a culture of continuous collaboration, feedback, and learning, which allows us to be, have that continuous improvement throughout the life cycle. Not just, we develop this, then we put it into operations and then figure out how to improve it. So lean Agile goals focus on a number of ways of approaching this problem. As you can see on the right-hand side, the lean Agile goals are to build the right product. What does that mean to systems engineers? That means that's validation, right? We validate, we build and develop the right product. The next goal is build the product right. That translates to verification in systems engineering. We build a productive environment for the right team. That means we're leveraging individuals and team innovation to improve the people, processes, and tools that we use. And we build better. We build better is another goal of Lean Agile, which means we're always continuously looking at and continuously improving our processes, our people, our tools, and therefore the way we develop our products. So typically, people think that Agile applies mostly to software engineering and to small teams, but really, it really applies to all the teams in the value stream, all those teams that are working in the value stream to develop that solution for the customer. As I mentioned earlier, it could be hardware engineers, it could be software engineers. We have to integrate, right, the hardware and software at some point. So it could be those INT or integration and testing teams. And so all of these teams really would benefit from working in applying Agile methodology. So let's look at some of the methods or techniques that systems engineers can use from the Agile methodology and applying Agile methodology. So this really is from Scaled Agile Framework. And as I mentioned earlier, Agile can apply to small teams, but also teams of teams, and so on, the whole value stream, right? Because in a team, you need to really work together and coordinate and collaborate within that team. But when you're building a component part of a system, you need to also collaborate and innovate with the other teams that are developing the other components, and understand how those two things that you're building, the two teams that are building different components, or many teams, how their products are going to evolve and interact in order to develop a solution, a coherent solution for the customer. So systems thinking is one of the techniques. Or Scaled Agile Framework is based on the 10 Lean Agile principles that you see here. And the second principle is systems thinking. And systems thinking is about taking that holistic approach to developing solutions for our customers. We start with the end in mind. As I mentioned before, we kind of have a picture, like that puzzle, right? We kind of have a picture of what that end game is going to look like. So we start with the end in mind and incorporate all of the aspects of systems and its environments into the design, development, deployment, and operations as early as possible in the life cycle. By doing this, we start to better that picture for our customer, how it's going to operate, how we're going to develop, and eventually how it's going to be fielded and used in the field. So in other words, we just don't look at the components separately, but we look at how that puzzle is going to look at the end. It's going to look once it's fielded, and how it's going to be used. So this picture here illustrates the three aspects of systems thinking. The very first one is the solution itself is a system. And what this means is we need to understand the boundaries of the system, optimize the system, not just the components, because optimizing the components doesn't mean that the system will be optimized. So we need to really understand the intended behavior of the system and how the components will work together. Also pay attention to the interfaces and interactions, right? And the system can evolve no faster than its slowest integration point. The second aspect of systems thinking is the enterprise building the system is a system too. And what that means is this involves the people, process, tools of the organization that's building the system. Building a complex system is a social endeavor. As I mentioned earlier, we need to collaborate across the different disciplines to understand the problem, to bring all those different discipline aspects to be considered at the onset or as early as possible in the process, so that we're developing feasible solutions for our customers. And then the last one is optimize the full value stream. And what that means is, again, collaborating across all of the disciplines that need to look at the problem and understand the problem, so that we're incorporating those aspects as early as possible in the life cycle. Another technique is design thinking. And design thinking is used to ensure we are looking at the potential solution in a holistic manner. So systems thinking, design thinking, we're looking holistically at all life cycles of the system. What potential solutions we have, how is it going to be tested, right? How are you going to design it? How are you going to develop it? How are you going to integrate it and test it? And how are you going to field it or deploy it or put it into operations? And eventually, how are you going to sustain it and decommission it? So all of those things, design thinking and systems thinking really incorporate all of the disciplines that are needed and also in a holistic way as early as possible in the process so that we can start to address those requirements and the feasibility of potential solutions. So design thinking is an approach to product and solution development where divergent and convergent techniques are applied to understand the problem and design a solution and deliver that solution to the market as quickly as possible. We can discover to understand the problem, as you see here on the left-hand side, to define a solution on what customers view as desirable potential solutions. And these are defined in epics and features, and I'll talk to that in a little bit. Then next, we design and develop solutions to the problems quickly and cost effectively so that our customers can go ahead and try it and give us feedback. So the diagram on the right illustrates how we can break down the work to accomplish our goals. We have features are implemented into user stories, and then user stories are part of the team backlog and can be further broken down into tasks. But I'm gonna stay on this slide a little bit more because I like to really cover what are features and epics, right? But to start out, I like to talk about the product roadmap. And what is the product roadmap? So the product roadmap is the plan of action of how a product or solution will evolve over time. And so what does that mean? You have the problem or potential solution, then you kind of break it down into the roadmap and the themes. And the themes are an organization's goal that drive that creation of epics and initiatives. Then you break that down even more. The product roadmap then is visualized as a set of the initiatives that are plotted over time. And then those initiatives are broken down into epics, right? And then the epics drive a specific initiative, which which keeps the product developing and evolving over time. We talk about, the product roadmap, and the product roadmap is a really, like I mentioned, the plan of action over time. And when we talk in Agile terms, we talk about the program increment and also sprints in program increments of time box, which during which Agile teams deliver value to the customers. Typically, those time frames or that time box is 12 weeks or 3 months in length. And then you can define, once you allocate your plan on how you're going to develop and evolve the product over the product roadmap, say over a year's time. So that gives you about four program increments, right? And then you kind of break down into the epics. Then you allocate the epics to the timeline. Then you break that down into features, and those features are allocated to program increment, right? And then you take those features and break them down even further to user stories, and those user stories are allocated to sprints. And sprints are it's another a time box, which is a 2-week, typically a 2-week, and most desirably a 2-week time box for those teams to develop that part of the requirements of that feature that you're developing, that you're going to deploy or provide at the end of the program increment. So user stories identify what someone wants to accomplish with your product and why, right? So we break it down to that level. And in systems engineering, that is requirements decomposition 101, right? We start out with the system components, then we subsystem components, then we decompose to components and so on, right? So that's really how we decompose the requirements in an Agile way so that we deliver value to our customers as soon as we can and get that feedback from them so that we can improve upon right away, not later on down the line when it's more costly to do so. So how am I doing on time? I'm doing pretty good. Okay, so the next, so let me back up a little bit because I did have an example of how we can break down into the features and so on. So let's just for a minute think of, we're working for a space travel organization, and we do 4 different launches per year. And this is really a perfect epic, right? Because it will take many people to contribute to the development of that launch. So for example, an epic would be Q1 space tourism launch. And so this can then be broken down into the features and then user stories by the different teams, right? So maybe, for example, for your software team, an example feature would be update range to include Q1 launch dates or promote summer sale. That would be like maybe something that you need to do for your website, right? And how you're going to break those features down into user stories that will help you accomplish that functionality or that feature over your Q1 or your program increment. Maybe the propulsion team has a feature based on that epic of Q1 space tourism launch. Another team has a feature that is related to that epic. It's a different kind of feature, right? Because they're focusing on a different type or different functionality for the system or solution that they're developing. And so maybe an epic or a feature for them would be reduce overall fuel consumption by 1%, or keep fuel tanks PSI greater than 250 ppm on launch, and so on. So we have the epic that many teams can work on, but each team will have to define the features that would contribute to delivering that epic. And then each team will then define the features and user stories, and the user stories are defined so that you can deliver that feature, which then will deliver that epic, which then will deliver that theme. And then pretty soon you'll have your roadmap all accomplished because you lay down that path of how you're going to accomplish and solve and evolve that solution over time. So that is very helpful because then you can learn from what you learn as you develop new functionality, or if you run into a roadblock or impediment, as we refer to it in Agile, then you can make a decision to shift and go maybe in a different direction. But you're also looking at your trade studies and potential solutions. Then you're down selecting those potential solutions and so on. So you can do this incrementally. So moving on to the next slide, another technique is set-based design, which is a practice that keeps the requirements and design options flexible. And as long as possible during the development process. And for example, instead of choosing a single point solution, the set-based design identifies and simultaneously explores options, eliminating the poor options over time. What is this? Systems engineering, trade studies, right? So the example that you see here, designers for a future autonomous vehicle have to select the technology to support the new initiative of prevention of forward collision. And then they select 3 options to evaluate, as you see here, the light detection and ranging, the camera, and then radar. And then they have the roadmap, as you see on the right-hand side of the picture, to go through and evaluate and make that decision, that forward collision technology decision in the very beginning of the 3rd program increment, as you see by the picture here. So they select 3 options to evaluate, then define the work that it's required to explore each of the options, as you see here in the picture. And then each option considering cost trade-offs, environmental issues, or alternatives, and design alternatives based on the validated learning that they're doing incrementally over the time of the program increment. Then I think this is probably my last slide. This really is it's another technique or another key aspect of Agile is the continuous exploration, which fosters innovation and alignment to customer needs and builds on what should be built in alignment to what should be built by continually exploring a market and customer needs and defining a vision, the roadmap that I spoke about, and set of features that addresses those needs. So having that continuous exploration drives the innovation, right, and fosters that alignment to customer needs, or understanding how our customers' missions are changing and being able to hypothesize to capture some ideas and also measure, how come up with ideas on how to measure those and validate those ideas. Then we collaborate to do research and refine our understanding of the potential problem and customer needs and help them understand how we're going to develop that system or component or solution. We architect a technological approach to enable quick implementation and delivery, and also support operations, having that systems thinking, holistic approach to delivering a solution for our customers. Then we synthesize to organize ideas into a holistic vision. We develop that roadmap, which then tells us this is our plan of attack. This is how we're thinking right now based on the knowledge that we have, how we're going to develop that solution. And then by prioritizing and breaking it down into the epics and features, then and user stories, then we can allocate those by time box, right? We allocate the features to the program increments, and then we allocate user stories to sprints. And so by having that mapping of, and mapping of your plan, you can define and break down the work, get as far as that knowledge and exploration allows you to get to a point where you can make a decision whether to continue on building up and improving on that solution that you've so far developed, or make a shift to another potential solution because you found out through your exploration that maybe that solution you were exploring wasn't as feasible as you thought, or it could be, or may not be the feasible solution that you want for your customer or the problem that you're trying to solve. So it is really a very exciting time because there's a whole movement, right? I mean, our customers, industry has been applying us Agile methodology for over a decade now. That kind of, I heard that you had a lot of computer scientists in the group. And, that really goes with DevOps, right? And DevOps is really about the collaboration in building that or bringing down those walls between the teams, because that allows us to communicate better, more efficiently, quicker, and understand each other's lens that we're applying to that problem that we're trying to solve for the customer, which allows us to more efficiently and quicker develop a solution for our customers.